All right, so the first thing I want to highlight here is a drawback to the analysis of variance test. And if you notice, the light is completely different. I actually went out and got my vaccine and came back and then kept doing this. So it's like 3 hours later than when you first heard me start talking. One drawback to the analysis of variance test is that although it tells you that there is a difference in your sample means if you reject the null hypothesis, it doesn't tell you which population means are likely to be different from each other. So it tells you that from the sample means you got, it's unlikely that they were drawn from populations with the same mean, but you don't know which one's actually different. So if you were to graph the levels of perceived police fairness in these suburban, urban, and rural areas that we were talking about in that last example, it would look like this. So we have 6.5 as a mean, 4 as a mean, and 8 as a mean. So these are our sample means. But what we don't know is whether in the population we found that urban residents are less positive about police fairness than rural residents, whether urban residents are less positive than suburban residents, or whether suburban residents are less positive than rural residents. And it's possible that all of these differences are statistically meaningful and that in the population there are different means across all of these three populations. So suburban population, urban population, rural population. But we don't know that for sure. All we know is that there's at least one difference among all of these. So it could be that the only difference is between urban and rural residents, and everything else is the same. Or it might not be. We just don't know. And so the only thing we can take away from the analysis of variance test is that the population means are not all the same. So at least one of them is different. And you can usually look at the sample means and get a sense for what the story might be, but formally and statistically, we can only say that there is at least one difference among the population means. All right, so I'm also going to go through an overview of the analysis of variance test in statistical software, so Stata, which is what I've been showing you throughout. And just to give you another hint for why we're doing this, for the applied data analysis project that I mentioned, you're going to be looking at real data that has been analyzed in Stata and interpreting it to learn something about the United States population. So it's important to be familiar with some of the Stata output and what to look for in it. Although, of course, I'm always around if you have questions, so it's not like learn it now or never learn it. So this is the analysis of variance in Stata. And I'm going to use the class survey again. We're going to pretend that the class survey is a simple random sample of CJ students and that we can use the class survey to learn about Rutgers criminal justice students overall. And I pulled out two variables from this, kind of just for fun. So the first thing that we'll be looking at will be grouping students by their political ideology. So this is actually a recode of a variable that you were asked, so if you remember way back, I don't know why you would, but if you do remember, you were asked if you're very liberal, somewhat liberal, moderate, somewhat conservative, or very conservative. Here, anybody who answered very liberal or somewhat liberal is considered liberal, and anybody who answered somewhat conservative or very conservative is considered conservative. So we have three groups here of students. And what we're going to do is compare the mean number of tattoos among those three groups of students in this class. And we're going to use that to see if among Rutgers criminal justice students as a whole, students who have different political ideologies have different numbers of tattoos. So the hypotheses that we're going to be testing are going to be whether the mean number of tattoos is the same for liberal, conservative, and moderate students in the population, or whether these different groups, so liberal, conservative, and moderate, whether there are differences in the number of tattoos that you guys all have. And again, we can only rule out the null hypothesis, which is that the number of tattoos is exactly the same for each group. We will not have any information about which group, if any, differ from the others. So the politics variable is coded in Stata, and remember, coding is just assigning a number to different categories for the purposes of number crunching. So here it's coded so that Students who are liberal are coded as 1, students who are moderate are coded as 2, students who are conservative are coded as 3. It's completely arbitrary, you could have flipped it around, but this is just how it is input into the program. And here's what the output looks like. So as usual with Stata output, there's just a ton of stuff going on. So what I'm going to do is just walk through the important pieces and the pieces that we've already come across while doing this by hand. The command for Stata is what's at the top where it says one way. There's different kinds of Anova tests. This is just looking at one variable across different groups, which is why it's called one way. Tattoos is the variable that we're interested in, so the means that we're looking at. And then libcon is the name of the variable that is coded so that liberals are group 1, moderates are group 2, and conservatives are group 3. Alright, so things to note about this output. In that first column there, we have numbers 1, 2, and 3 referring to groups 1, 2, and 3 based on how the variable was coded. So that first row there where it's group 1 is information about students who identified as liberal, group 2 is information about students who identified as moderate, and group 3 is students who identified as conservative. Here, under this column titled mean, are the sample means. So liberal students had 1.8888 blah 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 tattoos on average, moderate students had 1.46 tattoos on average, and conservative students had 1.57 tattoos on average. So as you can see, there's some differences. Liberal students have the most tattoos, moderate students have the least number of tattoos, but they're all pretty similar. So the question here is going to be, do we have enough information based on these samples and these sample means, and then the standard deviations and sample sizes you can also see in those rows there. Do we have enough information based on these 3 samples from the class to say that liberal, conservative, and moderate students have different numbers of tattoos among criminal justice students as a whole? Yeah, so here's also the sample ends. You can see our class skews relatively liberal, so we had 18 people who identified as some kind of liberal, 28 people who said they were moderate, and then 7 people who said they were conservative. We also have information in this bottom piece of the output as well. So we have our mean square between, which describes the differences between the groups. We have our mean square within, which describes how spread out the members of each group are from each other in terms of their numbers of tattoos. And then those are used to calculate your F statistic. So here we have an F statistic of 0.15. In our last example, it was 7.4, so here you can see this is a much smaller F statistic than we had in the last example. And finally, the most important part of this is underneath my head while I'm talking, but I'm already pretty far into this slide, so I'm just going to keep going. But it is the p-value. So the number that we have right there, and I'm going to move the slide around so you're going to see me talking about how it's under my head, and it's not going to be under my head while you watch it, which is fun. But the p-value, which is now highlighted, is that probability that if the mean number of tattoos were the same for each group, we would see results as extreme or more extreme than the ones we got. So what you can see from this p-value here is that at any traditional level of significance, so at an alpha of 0.05 or 0.01 or 0.001, we would be failing to reject the null hypothesis. So our p-value is larger than any traditional alpha level. There's a really, really good chance, in other words, that if liberal, conservative, and moderate students, CJ students at Rutgers all had the same number of tattoos, that we would have gotten sample differences as big as the ones as we got in the class survey. So in other words, unlike the example on the .cam, this would be an example of failing to reject the null hypothesis, and so we would not be able to rule out the idea that the number of tattoos among students of different political ideologies are different. Also, again, as with any hypothesis testing, we can fail to reject the null hypothesis, but we don't ever accept the alternative hypothesis. Because it could be they're different, we just don't know either way. But we don't have enough evidence to rule out our null hypothesis, which is that liberal, conservative, and moderate students have the same number of tattoos. All right, so the last thing I'm going to do here is just quickly summarize the hypothesis test for means that we've met so far. Because next week we're going to be talking about some things that involve hypothesis testing, but we are going to be changing gears and doing something a little bit different with it. So this is going to summarize what we know so far about hypothesis tests for means. So a couple weeks ago we met the one sample t-test. And the one sample t-test lets you answer the question, is the population mean value equal to some number that you're interested in? If you reject the null hypothesis in a one sample t-test, you conclude that the population value is not equal to whatever that number is. So you think the average sentence for robbery is 10 years, you could rule that out using a one sample t-test if you get a sample mean that's far away from 10. The two sample t-test lets you ask the question, are two different population means equal to each other? And if you reject the null hypothesis in a two sample t-test, you can conclude that those two population means are not equal to each other. So here you want to know whether the average sentence for robbery and the average sentence for burglary are the same. You could take samples of those sentences, compare them, and if they're far enough apart, you would have evidence against the hypothesis that they're the same. And then finally, today we met the analysis of variance test, which lets you ask the question, are three or more population means equal to each other? And if you reject the null hypothesis, you can conclude that all of the population means are not equal to each other. And at least one of them is different. Maybe they're all different, maybe just one of them is different. If you got a bunch of them, maybe two of them are different and some of them are the same. We don't know, but we do know that they're not all the same if we reject the null hypothesis. And for all of these tests, the things they have in common, you start by writing out the null and alternative hypotheses. You find a test statistic, which could be t or it could be f, depending on the test. And then you use that test statistic to calculate a p-value, which will let you decide whether to reject the null hypothesis. All right, so that's just a quick summary of what we've been doing so far. That's also the end of my material for today. So as usual, we have a problem set due on Sunday. Any questions, feel free to email me, set up a meeting, drop into my office hours / review session, which is just that open Zoom session for, just click on the link, pop in, and I'll be there. And otherwise, have a great week.